Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. A team of scientists studying the X-ray emissions of a so-called neutron star tell us that the existing theoretical models cannot explain what they're seeing. Astronomers say that neutron stars are very small, yet massively dense objects that spin at incredibly fast speeds, with rotation periods no more than hundreds of seconds, and sometimes faster than a dentist's drill. However, according to new research, a so-called neutron star has been observed with a rotation period of 5.4 hours, an anomalously slow speed. The neutron star is also unusual in that it is paired to form a binary with a red giant, and the magnetic field around the neutron star is surprisingly strong. According to an article on the phys.org website, these findings challenge our understanding of these extraordinary astronomical objects. However, no one has ever seen a neutron star. Rather, astronomers infer the theoretical object's existence based on their analysis of energetic emissions in deep space. But can a better explanation be found in the domains of plasma cosmology and the electric universe?
In a book titled The New Astronomy, first published in 1948, Hans Alfvén wrote a chapter called Electricity in Space. He wrote, "There is one great branch of physics which up to now has told us little or nothing about astronomy. That branch is electricity. It is rather astonishing that this phenomenon, which has been so exhaustively studied on the Earth, has been of so little help in the celestial sphere. Electricity has illuminated our cities but has shed no light on stellar phenomena. It has linked the Earth with a dense net of communications, but has given no information about the universe around us." End of quote. Hans Alfvén wrote that 66 years ago. Such is the inertia of the juggernaut of institutionalized science and education. Hans Alfvén drew the sun's circuit and emphasized the importance of electrical circuits in astrophysics. This Nobel Prize-winning scientist and electrical engineer is ignored. He predicted an astrophysical crisis must result from this ignorance of electrical activity in space. That crisis is unacknowledged, but it can be clearly seen in the science fiction-like headlines about black holes and so-called neutron stars. We have no evidence whatsoever that neutrons can exist for more than a few minutes without the close company of protons to form an atomic nucleus. To emphasize the problem in particle physics, Scientific American last month splashed the headline, "A Crisis in Physics if their theory of subatomic particles doesn't pan out," right across its cover. "Scientists need a new way to explain the universe," it said. But no one seems to pay any heed to these crises. Scientists have had 66 years since Alfvén's first warning, and he gave it again in 1970 at his Nobel Prize acceptance speech. A neutron star is one of the denizens of the weird zoo of objects dreamt up by astrophysicists in a futile attempt to explain intense bursts of energy from tiny regions in space. When all you have to provide that energy is the weakest force in the universe, that is gravity, then simple mathematics says you need whole stars squeezed into a tiny space to provide enough gravity. Wikipedia, that well-known source of facts about things we don't know, says a neutron star is a type of stellar remnant that can result from the gravitational collapse of a massive star during a supernova event. Neutron stars are the densest and tiniest stars known to exist in the universe. Although having only the radius of about 10 kilometers or 6 miles, they may have a mass of several times that of the Sun. But hidden in these artificial facts are the real facts. First, a supernova explosion is not understood. That has been admitted recently, but it hasn't changed Wikipedia or any textbooks for that matter. It's an outrageous assumption that a star first implodes before it can explode. It's an outrageous idea that gravity can overcome electrical forces within atoms that are 1,000 billion times stronger than gravity. And supernovae have a fine filamentary and bipolar structure that looks nothing like anything an explosion can create. Back to Wikipedia again. Neutron stars are only 12 to 13 kilometers by radius and spin around as rapidly as 642 times a second, or approximately 38,500 revolutions per minute. This isn't just science fiction, it's pure fiction, and nothing to do with science. It came from the discovery of rapid pulses of radiation, originally dubbed little green men, or LGMs, upon their discovery by radio telescopes. But since electrical energy is taboo in astrophysics, the only answer is a mechanical spinning lighthouse called a neutron star. But the electric universe follows Alfvén's sound reasoning. Electric circuits are easily capable of generating trains of pulses of radiation, so it makes perfect sense that these signals are not due to a lighthouse effect from a spinning object. And a paper was published by the IEEE, that is the Institute for Electrical and Electronic Engineers, the biggest professional organisation in the world, back in 1995 that showed how such an effect could be produced electrically in the magnetosphere of a normal star. In that paper, the results support the stellar magnetosphere, where the extent of the magnetosphere, not emission points on a rotating surface, determines the pulsar emission. Neutron stars generally exhibit strong magnetic fields, and magnetic fields are due to electric currents. The stronger the magnetic field, the stronger the electric current, and this could be the driving mechanism for the pulses from neutron stars. What's more, it could explain the fine details observed in the pulses. That's how science should be done. But astrophysicists don't talk to plasma cosmologists. That is not how science is supposed to be done. This particular report, headlined Slowly Rotating Neutron Star Paired with a Red Giant Star, makes the point that whereas neutron stars usually have rotation periods of hundreds of seconds or shorter, this system is unusual in that the rotation period of the neutron star is about 5.4 hours. Of course, electrically, this is not a problem. You can have oscillators that run at slow speeds such that you can hear them. They're in the audible range, or you can have them operating at such high speeds that you need a high-frequency radio receiver to pick up the signal. In the case of neutron stars, the signal is so intense and of such high frequency that it is picked up generally now in X-rays. The article finishes with, in our galaxy, nearly 2,000 neutron stars have been discovered and have revealed a large variety of types, whose diversity, evolution, and physical behavior remains poorly understood. The results therefore unearth new questions on the birth and evolution of systems such as this one. For example, why does such a high magnetic field neutron star exist with a comparatively old star as a companion? The electric universe model explains all of these. If you have an initial model which is missing the most powerful activating force in the universe, the electric force, and then you talk about the ages of stars based on the thermonuclear model of stars, all of that is incorrect. So it's not surprising that the diversity, evolution, and physical behavior of neutron stars remains poorly understood.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.